Welcome, I'm S. Nitish. Now I'm going to explain about different types of solids. Before discussing about the types of solids, let's see what are solids and its characteristics. Solids, they have definite mass, volume and shape. In the intermolecular distance are short. Intermolecular forces are strong. The conjugate particles have fixed position and can only oscillate. They are incompressible and rigid. Now let's see about the types. There are two types based upon their atomic arrangement, binding energy and physical and chemical properties. The first one is crystalline and the other one is amorphous. Now let's see more about crystalline solids. The building consequents arrange themselves in a regular manner throughout the entire three-dimensional networks. Existence of crystalline lattice. A crystalline lattice is a solid figure which has a definite geometrical shape with flat faces and sharp edges. They are incompressibly orderly arranged units. They have definite sharp melting points, definite geometry, give X-rays diffraction bands. Examples NaCl, etc. This is the structure of a crystalline solid. Table salt is one of the examples of crystalline solids. Amorphous solid. They are derived from Greek word morphe, meaning shapeless. No regular but haphazard arrangement of atoms or molecules. Also considered as non-crystalline solids or supercooled liquids. No sharp melting point. Isotropic. No definite geometrical shape. Do not give X-ray diffraction bands. Examples glass, rubber, plastic. This is the structure of an amorphous solid. Cotton candy is one of the examples of amorphous solids. Now let's see some difference between crystalline solids and amorphous solids. Crystalline solids have regular internal arrangement of particles, whereas amorphous solids have irregular internal arrangement of particles. Crystalline solids have sharp melting points. Amorphous solids have no sharp melting points. Crystalline solids are regarded as true solids, whereas amorphous solids are regarded as supercooled liquids. Or crystalline solids undergo regular cleavage, whereas amorphous solids undergo irregular cleavage. Crystalline solids are anisotropic in nature. Amorphous solids are isotropic in nature. Crystalline solids have definite geometrical shapes. Amorphous solids have irregular shapes. Crystalline solids do not have smooth cooling curves, whereas amorphous solids have smooth cooling curves. Crystalline solids have definite heat of fusion. Amorphous solids do not have definite heat of fusion.